Hello folks, this is Derek Brown bringing you a video guide to the Strawbridges project. This video guide is designed to supplement the written Strawbridges project guide, which provides all the details, which sometimes buries and obscures the details. So hopefully this spoken and video guide will highlight and illustrate and lift up some of those key details to create a successful project. Here's how we're organized. I'll present first a project summary. We'll cover some key vocabulary. We'll talk about materials, costs, and sourcing. We'll cover the procedure and design criteria. We'll talk about activity extensions for the students who need more. We'll talk about activity scaling to differentiate instruction for students of different ages, aptitudes, and interests. It is worth noting that both the video and written project guides assume an audience of non-engineers. I am an engineer. I'm an electrical engineer. I'm also an educator. I'm also a communicator who has learned through experience to use neutral language to include everyone so that everyone understands. Let's start with the project summary. In Strawbridges, you'll have teams of 2 to 3 students designing and creating bridges using plastic drinking straws and tape. That's it and that's all. The goal is to design and build the strongest bridge, one that uses a pattern that the students will design and one that meets the design criteria and constraints that you, the instructor, will provide. Now, with instructor guidance, students can experiment with different geometric shapes to learn how shapes affect the strength of materials. Let's talk vocabulary. The first vocabulary term of critical importance is abutment. Abutment. These are masses that you place at the end of your bridge that exert upward forces. They push up on the bridge pushes down on the abutments. That's how the bridge stays still when cars and people start moving across it. The other term is a bit of a plot spoiler. That term is truss, T-R-U-S-S. Trusses are structural frames that use triangles. Now, once you define the truss, the cat is kind of out of the bag that the students want to use triangle shapes in their designs because triangles are rigid and strong, much stronger than squares and circles. Let's talk materials and costs. I am a Dollar Tree STEM designer. I like materials from the Dollar Tree because the stores are widely available, easily accessible, but Dollar Tree also will ship items to stores for pickup, or they will ship to your site. That flexibility and that efficiency makes it easy to get some of these STEM projects done. Now, each group is going to have a supply of regular drinking straws. Here's a footnote. When I visited the Dollar Trees in my neighborhood, they only had these flexible drinking straws. Now, that's what they have. Well, you can order the non-flexible straws, but if for whatever reason this ends up being what you have, you can make some adjustments, which we'll talk about later. They'll need invisible tape. They'll need scissors. They look something like these. They'll need rulers because they want to measure twice so that they cut once. And then for the entire class, you'll need at least one of these. It'd be better if you had several cups filled with some of these Dollar Tree marbles, pebbles, rocks, whatever you choose. I think I put a purchase link in the written project guide for rocks because the rocks are a little smaller. You can add the weight in with a bit less detail. And then you'll need a support structure. My suggested support structure are these equally sized canned goods. This is what you will use as your abutments. Your bridge will rest on top of these. Small postal scale to weigh the cup and the pebbles, rocks, pennies, whatever, that create the weight that breaks the bridge. When you're testing the bridges, you're going to break each one of them by sitting these on top of them. And then there's also a link to an egg timer that you can run on a computer, project onto the screen. That allows you to maintain some timing and synchronization between the different phases of the project. You're designing, requires some time. You're building, you're testing. All of that requires time. The egg timer will help you stay organized. I've already mentioned the straws. We'll talk about the design criteria and how to make the adjustments if you have the flexible straws. Let's get to that now. Your procedure and design criteria. Your teams are making model bridges using straws and tape as their only construction materials. Their challenge is to make a bridge that will sit on these abutments. These abutments will be 10 inches apart. That means their bridges need to be a little bit longer than 10 inches so that they will sit comfortably on the abutments. Your bridge has to have a place to sit this cup. When it's tested, you're dropping these pebbles in one by one. Make sure you drop them slowly enough so you can determine the one that makes the bridge break, and do that accurately. And you want to record those weights for each of the bridges. How do you extend this activity for students who need more? This notebook, also available at Dollar Tree, is the key to extending the activity, because the engineering design process and reflecting on it is something that you can have your students write about in these engineering notebooks. The engineering design process includes defining the problem, brainstorming ideas and designs, selecting the most promising design based on presented criteria and constraints, communicating that design both to technical and non-technical audiences to get their buy-in and confidence, creating and testing the design, evaluating and revising the design, having the students reflect and write about what they did in each of these areas, especially evaluating and revising, because we never come up with the right answer the first time. We may never come up with the right answer, period, because in real life, the right answer probably always escapes us. But we do come up with an approach that satisfies the customer, that provides a robust solution that is low cost, if that is the key design constraint and criteria. Now, another thing you can do to extend this is that students can investigate other real-world uses of truss systems. There are many. The roofs on all of our houses, the frames on our bicycles, ramps, towers, cell phone towers, radio towers, they all make use of the rigidity and strength of triangles in their structures. How do we scale an activity like this to differentiate instruction? Well, your primary design constraint is that your bridge has to be a little bit longer than 10 inches to cover the distance between these abutments. Well, if you have younger students, you can make that distance less than 10 inches, less than 8 inches, less than 7 inches. If for whatever reason these are the only straws you have and you have to cut them, well, when you cut this, it probably is going to be a little bit less than 7 inches. So you may have to adjust anyway. And then for younger students, you may tell them that they can make theirs 5 inches. The shorter the bridge span, the easier it is to build a stronger bridge. The longer the bridge span, the more difficult it is to build the bridge. So for your older students, you can make them have their bridge spans be a little bit longer than you do for your younger students. You can also allow your younger students to use straws in vertical positions to support the weight that the bridge has to bear. Don't allow the older students to do that. Let the younger students do it. Those are a couple of ways that you can adjust this and scale it. Now let's conclude. This is a great first project. Accidentally on purpose, I like for this to be the first project because it's straightforward, it's visual, and it's got well-known real-world applications because bridges are everywhere. Be mindful now that design, testing, scaling, and extending the activity could make it take more than the 4 allocated hours very easily. So manage your time carefully and save it by having multiple sets of abutments and multiple cups and pebbles so that you can test multiple bridges simultaneously. You may even want to consider having at least a second scale that'll allow you to get through that part of it easily, bring the whole thing in and finish it. Have fun with this one because it's designed to give students and instructors confidence to do this STEM stuff, right? And it helps to build solid relationships between the teacher and the student, and between the students and between the teams. Take care. Good luck. And most of all, have fun.